This is Algebra 2, 3.1, Solving System of Equations. There's three different ways to solve a system of equation. 1 by graphing, 2 by substitution, and 3 by elimination. If you're graphing them, you have to put them in slope-intercept form and then graph. Substitution, one variable has to be alone, and for elimination, everything has to be lined up. Your x's have to be lined up, your y's have to be lined up, your equal signs have to be lined up, and the number by themselves has to be lined up. So go ahead and open your book to page 112. On page 112, you see three different graphs there: consistent and independent, consistent and dependent, and inconsistent. So what you're trying to find when you're solving a system of equations is where they cross at. So the first one, consistent and independent, it crosses one time. There are two linear lines that cross one time. They will never cross again. They intersect once, and they have one solution. Consistent and dependent, there are two lines graphed there, but when you graph them, they end up being the same line. So that means it's infinitely many solutions, because at every single point, those two lines touch. And the third option our answers could be is inconsistent. Inconsistent means these lines are parallel and you have no solution. They will never cross each other. So let's start with some examples on graphing. So the very first one that we're going to graph is 2x minus y equals -1 and 2y plus 5x equals -16. So to graph them, you have to put them in slope-intercept form. So we have, let's start with our first one, 2x minus y equals -1. Subtract your 2x over. So -y equals -2x minus 1. Divide by -1, so y equals 2x plus 1. There's one of our equations. Our one that cut off there. On the second equation, let's subtract the 5x over, so you have 2y equals -5x minus 16, and then divide everything by 2. So you have y is equal to -5 over 2x minus 8. So let's go ahead and graph function 1. So it crossed at +1 and went up 2 over 1 because it had +2 slope. Up 2 over 1. This isn't an inequality, this is an equation, so you don't have to worry about solid or dashed lines, you just graph them. Arrows on both ends because we have lines that go on forever. So that's line 1. Line 2 crossed at -8. And it has a -5 over 2 slope, so we'd go down 5 to the right 2. But I'm out of room, so I'm going to go up 5 and 2 to the left. So we've already found our crossing point. So this line has one solution. And then you have to name that solution. So it crosses at -2, -3. So it's a coordinate, so it's got parentheses around it and everything. So problem number 2. 4x plus 3y is equal to 12, and I'm going to write them side by side because I know I'm going to have to put them in slope-intercept form. And the second one, -6x plus 4y equals -1. So on the first one, put it in slope-intercept form. 3y equals -4x plus 12. Divide by 3. So y is equal to -4/3 x plus 4. Okay, on the second one, 4y is equal to +6x minus 1. Divide by our 4. And y is equal to 3 over 2 x minus 1/4. So let's go ahead and graph these. So the first one crossed at +4, had -4/3 slope, so down 4 over 3. down 4 more over 3. If you wanted to go up, you could go over 3 as well. Line number 1. Line number 2 crosses at -1/4. So about right there. Goes up 3 over 2. So this one's kind of an estimation, and this is why graphing is not very good in solving systems of equation, because you don't get exact answers. Some of them are crossed in between. For example, this one, and you don't get an exact answer. So it looks like this one crosses at approximately 1.52, and so that's all we can say. This is an approximate answer. We don't know for exact where that crosses. And let's do a third one by graphing. -3y plus 8x equals 36. There's our first equation. And the second one, 6x plus y equals -21. So in the first one, we have -3y is equal to -8x plus 36. Divide by -3. And so y is equal to 8/3 x minus 12. The other one's a little easier to put in slope-intercept form. All we have to do is subtract that 6x. And we've came across our other problem with graphing. These equations are so big that when I graph them, I would have to graph at a -21, go down 6 over 1 to the right. On the other one, I'd have to go down to -12 and then up 8 and over 3. My graph's not big enough for this problem. So algebra really would help me with this problem. And so for my next examples, we're going to solve these by using algebra. And so I'm not going to graph this one. This one I just did just so I can show you that sometimes graphing is not the best option for solving system of equations. If they're already in slope-intercept form, go ahead. If you like to graph them. But if they're not, I would not use graphing. I'd use substitution or elimination. And that's what we're going to learn in our next video.